Welcome to this lecture. In this lecture, I am going to solve a problem. The problem is as follows: that in this, I want to show that every square matrix or every matrix representation of a component of J which satisfies J cross J is equal to iota H cross J has zero trace. Here, J is the angular momentum, right? So let us try to solve this problem. As given in the problem that J cross J is iota H cross J, which implies J y J Z, because I will take its cross product, and its cross product comes out to be J y J Z J Z J y I cap plus J Z J X J X J Z. It's a simple vector algebra approach. You can do it at your own. Minus J y J X, and it is K cap. It can be written as iota H cross J X I cap, iota H cross J y J cap, and iota H cross J Z and K cap. So if I equate corresponding components and if I try to look at these various parts, then this part is basically J y J Z. It's commutator, and it is basically J Z and J X commutator, and it is the commutator and J X and J Y, right? So keeping all these things in mind and equating corresponding ith, jth and kth component, I can write down this as like this J y J Z minus J Z J Y. It is ith component, and it is equal to J y and J Z commutator, and it is equal to this component. So it is iota H cross Jx. Similarly, Jz Jx minus Jx Jz, and this is equal to Jz comma Jx, and this is equal to iota H cross Jy. Similarly, Jx Jy minus Jy Jx is equal to Jx Jy, and is equal to iota H cross Jz, right? It means I can write down from here Jx, Jy and Jz. So it means from here I can write down as Jx is equal to 1 over iota H cross Jy Jz minus Jz and Jy. And similarly, Jy can be written as 1 over iota H cross Jz Jx minus Jx and Jz. And similarly, I can write down Jz is equal to 1 over iota H cross Jx Jy minus Jy and Jz. Now let me recapitulate certain properties of trace. So the properties of trace are like this: that trace of A plus B, it can be written as trace of A plus trace of B, or if it is minus, then it will be minus, right? And similarly, trace of AB, there is another very important property, it is the trace of BA. So it is trace of BA. If I do this, then let us now consider this first part. So if I consider this, then trace of Jx, as I know that from here, yeah, it is Jx is equal to 1 over iota H cross Jy Jz minus Jz and Jy. This implies that trace of left hand side is equal to trace of right hand side, because both are equal. Right, so I can write down it in this manner. it means this can be taken outside. So it is 1 over iota h cross, and I can write down it as trace of jy jz minus jz and jy, and if I use this property here, then this can be written as 1 over iota h cross trace of jy jz minus trace of jz and jy. But using this property, these both are equal. So that means I can say that trace of jy jz, it will remain as it is, but this can be converted into trace of jy and jz using this property, and both becomes identical. So that means it will cancel out and it is equal to 0. So that means now I have proved that trace of jx is equal to 0. Similarly, I can prove that trace of jy is equal to 0 and trace of jz is equal to 0, and that's what is asked to prove, right? As the zero trace of what? The components of J and which satisfy this particular relation, right? So that's all for this problem, and in the next lecture I will discuss more problems, and thanks for watching this lecture.